Okay, welcome to our next community workshop. It's new rebranded, all skills, no shills with Chainlink Hackathon winner 0x Thresh. He is going to give us a lowdown on Docker and why to even use it, how to use it in Web3. For people that struggle like me, I've been trying to learn Docker and I don't care about the history of Docker. I don't care who invented it. I don't care why I should love it. I just want to learn how to use it, right? So Thresh is going to give us a lowdown of like why you need it, how are you going to use it, what are the scripts to get started. No better than a hackathon winner, right? So I'm going to let you take over the show, Thresh. Let them know what's up. The audience is yours.
Sweet. Sounds good. Thanks, Billy. I'm going to teach you about some Docker today. A couple ways this is going to go through. I've got some slides. I've got some live walkthrough. The main thing to know real quick is that as we're going through this, there is a quick start repo in GitHub. Highly recommend if you're wanting to follow along and maybe have some of this stuff for later reference without having to rewatch the whole presentation, that you check this out. This has all of the commands that we're going to run and all of the details that I'm going to walk through in the workshop here. So this will be a good starting point for anybody who wants to follow along. All right, and with that, here's what we're going to talk about today. The first thing we're going to talk about is, what is Docker? I promise it's going to be super quick. We're not going to give you the life story. We're going to talk about installing Docker. We're going to talk about finding public images. We're going to talk about building containers. We're going to talk about building your own images with your software that you've written. And then we're going to give you some tips and tricks once you've got the basics down. So what is Docker? Well, for those of you who haven't already heard of it, Docker is a software platform that allows you to build, test, and deploy applications quickly using containers. And containers are just a fancy piece of software that enables you to configure your application once, build it as many times as you want in a repeatable manner, and it enables you to distribute your software to other developers and allows them to use your code even faster. So when you're wanting to get your software out there and drive adoption, containers are a great way to go. Just make it as easy as possible for everybody to get the quick start that they need so that they can start running your sweet application as soon as they want. And here is the origin of how we got to Docker. Originally, if you're a dev, you've probably said the words, "It works on my machine," before when it didn't work on somebody else's. Docker is a solution that says, all right, we'll just ship your whole machine then, but no shipping your laptop to your customers required. So that's how we're going to use our Docker images today, is to get your "it works on my machine" out to the rest of the world. All right, some quick terminology. These are going to be really important because I'm going to use these words a lot through the rest of this presentation. The first word you're going to want to remember is an image. A Docker image is a blueprint of what needs to be on a running container, including your code, library, configuration settings, and any other dependencies that you might need to give to somebody else in order for them to run your application. It's similar to distributing something like a node modules or a package.json or anything like that. It's just so that whatever somebody tries to run your software, they've got the same starting point as you. So that's really what the image is going to do for us there. The next word you're going to want to remember is a container. The container is the live running version of your application that is built from that image. And we're going to talk about these a lot through the rest of the workshop, and it'll probably start making a little more sense. Just to give you a kind of a quick visual on this as well, this is straight from the Docker documentation for this image that we've got here. But basically, you've got these images. It can be Python, it can be Redis, it can be Node.js, anything that you're distributing as part of your application. That can be what makes up your image, and that is used to build as many containers with it as you want. It can be one running on your local machine. It can be 1,000 running in the cloud at the same time. Doesn't matter. The image is going to be whatever you need to help build that container. All right, so now we're going to talk about installing Docker, and hopefully this will go pretty quick for some people, but if you want to follow along, want to make sure you've got the time and instructions on how you want to do this real quick. So installing Docker is super easy, and thankfully it is also free. The way that we're going to do this is we're going to go to docker.com/products/personal here. And I've got this in another tab over here, so we're just going to go right over there. You can see there is this Get Started for Free page. You can go ahead and sign up for an account if you don't already have one. Just need to give them a username, email, password, and you should be ready to go. In my case, I do already have an account, so I'm going to do this sign in here instead. All right, and here we are on the Docker Hub page, and you'll notice right away that there is a download the Docker desktop application We've got options for Windows, Linux, or either type of Mac software or Mac processor that you might have. So just go ahead and click on the one that's best for you, get that install going, and we should be good to go. The good news for everybody is I'm going to do some talking for a little bit now, so you have some time to go ahead and get all that installed while I kind of go through Docker Hub and show you the rest of that. So that should give you a few minutes to let that install run and do what you need to do there. All right, so we're going to talk about finding public images. So a public image is really going to be any software that some specific company or project or anybody else wants to distribute to the public. And when they do that, they post their images somewhere publicly that everybody else can go grab those so that you're able to use their software without having to run their npm install or their pip install or whatever else that you might need to do if you were to just try to run their software directly on your machine. The best starting point for this is always going to be Docker Hub, which you can just find at hub.docker.com. Again, this is the most common place for projects to publicly store images that they maintain. And once you find an image that you want to use, we'll end up using a couple of commands to grab those. You can see some examples here, but we'll show you the rest of those later. Let's go over to the hub page for a little bit and kind of look through this. So coming back to that same hub.docker page that we were talking about before, you can see there's a few things here. There is a few container images right here on the front page for us, which is great. Bet a lot of you are looking for that Node.js one. We'll be using that later in the demonstration, so we'll get a view of that. But given that this is a Web3 presentation, I'm going to go ahead and start with something that we're probably pulling pretty commonly, which is going to be an Ethereum client. So in this search bar of the top of Docker Hub, we can search for anything, any type of software that we might want to use a container image of and see if they're already hosting something publicly for us, which is awesome. In our case, we're going to use the Ethereum client Go as our example for these next few sections here. And you can see that as soon as I search Ethereum, it's one of the first things that pops up. So I'm going to go ahead and click on this one. And right away, there's some awesome info for us about how to run this container, what it's made up of, and how we can use it. So just to kind of give a quick overview, this container image is what we would use to run an actual Ethereum client, and it's made by the Ethereum Foundation. We see some info about when it was last updated, so they last made a new version of this 25 days ago, and we can see that this has been pulled by developers over 10 million times in their particular case for this top right part. You can also see that they give us the command right here that we need to go download this container image if we wanted to, which is awesome. Anytime you go search for any container image, this pull command will always be here so that you can just copy that. You don't need to remember the commands. You can just hit the copy on this, paste it into your terminal, and be off to the races. Now, before we go over to that terminal, do just want to show a couple more things that are worth talking about on this page. So this is our landing page. Again, we've got our Docker pull command, a lot of really good info from the project maintainers about their software and what we can do with it. There is one other tab here I want to point out to everybody, though, and that is this tags tab here. So there is always kind of a default image that you might want to push out to people or that you may want to pull. In the case of the Ethereum client, they have like a pretty minimal version of the Ethereum client that they assume is going to be good for the majority of their users. The thing you'll notice down here, though, is that there is more images. And the one I'm going to focus in on here is this all tools latest. So you can see that this is significantly larger, almost or over 5 times larger than the base image that they distribute to everybody. This is because, presumably, this has all of the tools that an advanced user of the Ethereum client might need. And so they do distribute that as a separate image with a separate tag in order for those people to still have that image available without having to manually install all those extra tools on the image themselves. But Ethereum is also assuming that the majority of users aren't going to need these. So why add the extra 5 times worth of storage on their hard disk when there's a very high chance they're not going to need these tools? So whenever you're looking at some of these public images, it is worth going into this tags section and just making sure that you're getting the best container for your use case. A lot of the time in this overview tab, they'll kind of explain the differences, and we can look at a Node.js one as well where they do a better job of kind of breaking down the differences between tags. But just another way of pointing this out is you can see that some of these are for an ARM64 architecture, some are for an AMD64 architecture. So they're distributing these separately just based on what your CPU architecture on your computer might be, just to make sure that you're going to get the best experience based on what image you're going to pull. The other thing that's very nice about this is that you see we still have these Docker pull commands with the exact tag in the format that you would need. So if we want to pull this all tools latest, we're just going to click this copy button right next to that, paste it into our terminal just like we would have with the same pull command on the original page, and we'll get the exact version of that image that we're looking for. So just another helpful thing to know about Docker Hub. There's probably more than one use case, and you should probably check to make sure you're getting the best image experience that you can get just based on what they're distributing. Real quick, we can just go take a look at the Node.js one as well, since that is another very common one to use. And here you can see on the Node.js image that they have even more tags. Just another example of how to think about this. Here are some Node.js version 20, Node.js version 18, version 16. So they have different versions that have Node.js and NPM already installed for you on this container. So that, again, as part of building your images, you don't have to do that part manually. It's just already going to have that stuff ready to go for you and installed. And you just need to choose basically which version of this matches your project for whatever your code is going to do. So just another one to point out where they've got a lot of different tags and a lot of different functionality that you can pull from here. And we will use this node image later, so you'll kind of get to see what I mean by them making it easy on us with this. All right. And with that, we'll come back over here. I'm hoping at this point people have had a chance to get Docker Desktop installed if they wanted to go ahead and follow along with some of this. So that's kind of Docker Hub, and we're going to start actually running some commands shortly here and getting into it. The other part to talk about with finding public images, so we got through Docker Hub. The next part is actually finding the Docker files on somebody's GitHub repo. So sticking with our Go Ethereum client example there, I'm going to come back to their GitHub. And you can see here in the Ethereum Go GitHub repo, where they distribute the Ethereum client, they do have a Docker file here. And this Docker file is the instructions to actually build the image. And we'll walk through all of that in a bit. But the main thing to note with this is that when you are going through somebody's GitHub, you should pay attention to see if there is a Docker file there, because if there's a Docker file, rather than walking through all of these separate steps that we're going to have to do in order to build the source and do all of these configurations and everything else, we can actually just go down and look for any info on running this with Docker. And it's going to be a simpler process. Here, I've got that in my URL there, so we don't have to keep scrolling. But so here's their Docker Quick Start section in their repository. And you can see they have the exact command here ready to go for us to pull their image, actually run this as a container, and just start our own Ethereum client without having to do any of the manual installation. So that's going to be super helpful. We'll do that in a terminal in just a second here so that you can see what that's going to look like. But just another way to keep an eye on what you can grab from other projects publicly. There's a very good chance that they're going to be distributing a Docker file that you can just pull, get started with without having to do all of the extra config and installation to actually run their software. So this can be great for things like Chainlink nodes. It can be great for things like Filecoin nodes, Ethereum nodes, any other node that you may need to run. This is usually a great place to start, is just go see if the specific project has a Docker file or a Docker image on Docker Hub that you're able to pull from so that you can get that quick start for yourself. And now that we're through that, let's start talking about building some containers from these images. So when using images from Docker Hub, we can actually pull and build a container in the exact same command because it's smart enough to do that pull part for us. So we're going to go over to our terminal and start running some commands here so that everybody can see us start to build these containers and get an idea of what this actually looks like. One thing to note, you'll notice that on this command, there are quite a few flags. We'll break these down in the terminal, but just know that one does not simply run Docker without any arguments. There's good reasons to have these here. If you just run a Docker command with no arguments whatsoever, usually you're not going to have a good time. And we'll kind of talk through what that looks like in a minute here. At this point, we're going to go over to our VS Code. And we're in our Web3 Docker Quick Start here. So hopefully y'all have cloned that and had a second to kind of check that out. And we are going to go ahead and pull and run the Ethereum client image that we saw there. And so if you're following along in the GitHub, this is right under the building containers from Docker Hub section. There's a command kind of right at the top of that. That's where I'm pulling this from here. And you can see that this is what we're getting ready to run here. Now, before we actually run this, let's talk about what we're doing here and what each of these flags actually means. So Docker is always our base command that we're going to start with. No matter what, if we're working with Docker, you're using Docker. Docker has a lot of subcommands. You'll see a lot of them throughout the rest of this workshop here. But the first one we're going to start with here is this Docker run. And what Docker run is doing is telling Docker to take a specific image and actually turn it into a running container. That image name is going to be your very last argument. So as you can see here, we have our Ethereum client Go. If you're looking back at Docker Hub, that is going to be a perfect match with our Ethereum client Go that we have on this page here. So when we did our Docker pull Ethereum client Go, that is the exact name of the container image that we're actually going to pull here. Now, again, in this case, this command is going to be smart enough to do the pull part for us if we have not already done the pull manually. So we'll just go ahead and go through that. The first flag to note here is this -D. What -D means in a Docker context is detached. So if I don't have this -D here, basically what's going to happen is my live running terminal here is going to connect directly to the container that we run and the process that we start with it. In my case, I just want to start the Ethereum node. I don't necessarily want to connect my terminal to it. So this -D flag is just going to make it so that the container is going to run without essentially grabbing our terminal section and forcibly attaching it to the container that we spin up. The next flag that we have here is a name for, and I'm just naming this Ethereum node since I want to know exactly what this is doing. Basically, if you don't include this -- name flag when you do a Docker run, Docker will give a automatically generated name to your container, which is fine. But if you start spinning up 4 or 5 different containers at a time, you're going to start to lose track of which one is which, and you're not going to really know what you're doing anymore. So whenever I'm spinning up containers, I tend to try to give them a name just so I know which one is which, and I'm not losing track of everything as I start to run multiple of these. The next flag we have here, you'll see that we have this twice, is this -P. -P is for port. So I'm sure you're all familiar, like as part of your own software, especially if you're using stuff like Ethers where you need to set like a specific endpoint as your RPC endpoint. You're familiar with setting a specific port to that. You might be used to seeing like 8080 or port 3000 or something like that. That's exactly what we're doing here with this -P flag, is we're saying this container that's going to run with this software, I want that container to be listening on this port. And when I forward connections from my local machine to that container port, I want it to be listening on that exact same port. So really what that means is with these 2 numbers here, the first one is a local port that our machine is going to listen on. And the second port is the port that it's going to get forwarded to on the container. So basically the container is listening on the exact same port that our host would if we were to start this Ethereum client just on our machine instead. And it just ensures that any traffic that we would normally send to this port 8545 that should be for our Ethereum client, it's going to get to our container that's running that client, and the same traffic will pass through exactly how we would expect it to if the container weren't involved at all. You can see that we've got the -P flag here again. This one is just for port 30303. So we're just passing another port through, no change here. This is just something else that we want the container to listen on. And then again, like we said at the beginning here, this last command or this last argument is just the specific image that we want to pull from when we run this container. So that's kind of the breakdown of this command and what we're actually doing. At this point, we can go ahead and run this, and we should get a live running container once we do that. And if you see an ID like this, it means you're in good shape. You now have a running container that is a running Ethereum node on your machine. This isn't the most perfectly helpful thing in the world, though, because you might be looking at this and wondering, okay, now what? Here's what we do now. So another helpful command to be aware of is Docker PS. And this PS is essentially short for process, and it's going to show us all of the Docker containers that we have running right now. So as you can see here, when we run that Docker PS, we get all of this output about all of the different things that are running on this container. So it's telling us the name, it's telling us the, and I'm trying to clean this up a little bit so it lays out. There we go. That's a little better. So it's going to give us that container ID. This is just the short version of the long ID that it spat out up here above. It's going to tell us what image we spun this up from, which could be another helpful way for you to keep track of which container is which. This is the command that is actually executed when the container starts. So in the case of this, it needed to run the geeth command to start the geeth client. So that's the command that it ran. Here's how long ago we created it. This is how long it's been online. And here are the ports that are getting forwarded as part of our container build. And then lastly, we have the name that we gave the container, which was just this Ethereum node from up above. So that's how we can look at the container that we have running. Now, what do we do with it? At this point, we're going to kind of look through some of the ways that we can perform specific actions with this container that we just spun up. One of the first ways that we can do this is using a docker exec command. And what docker exec is going to do is this is going to allow us to execute a specific command against the container that we have running. This can be really useful to do things like make sure that a file that you think should be there is written to the system, or in our case, we're even going to get a full running shell on the system so that we can run a terminal on this and take any actions against it that we would like if this was running on our local machine. So real quick, let's do another quick breakdown of what this command is actually doing. So we talked through the docker exec. We have this -it. This -it is almost opposite of the -d, where -d is saying, I want this to be detached. -I is saying that we want this to be interactive. And what that means is we actually want to connect our terminal to the output of whatever command we're going to run this time. And then the T is also telling it that this is actually for a terminal so that we get a little bit nicer input back from the container. If you don't include the T, it just kind of shows as like a blank and you can't really tell that you're connected to something. But if you run commands, it'll still work. But the T just kind of makes it a little bit nicer of a user interface for you so you can keep track of what's happening. This Ethereum node here just matches up to the name of the container again. So we ran an Ethereum node container, and this is just the name of that. This is just telling it which container that we want to execute this command against. And then our last part here is /bin/shell. Really what this is doing is saying we want to run the bin shell command, which is just basically the terminal that we're going to run on this container. So really what we're doing is starting a terminal that we can connect to on the container since we have the -it. And here we are. You can see that this dropped me into a terminal. And if I just print working directory, actually right now it's just on root, but let's just change the directory to root and do ls-al. And the reason I'm doing that is just because you can see here that here is our .ethereum folder that you would be used to seeing if you were to ever start a geeth client. And if we cd into that, you can see that we have all of the geeth files and folders that you would normally expect to see on any running geeth node. So at this point, we're on the container. We're actually connected to it with a terminal, and we can see all of the stuff that we need to here. So let's say for whatever reason, we were using this client, but we're having issues like sending any of our requests outbound, and we think that it might be because we don't have a key set or something like that. Connecting our terminal to this allows us to actually go through and check all of that and kind of do some live debugging on our container so that if something isn't working the way we expected it to, we have a way to come in here and actually check it out and make sure that everything is in here as we'd expect it to. So connecting this shell to your running container instance is a really handy debug tool. It's also really useful for coming in here and doing things like looking at logs or making sure that your app is actually running with the right command and things like that. So you don't necessarily have to use a bin shell when you're doing exec. You can actually just run any command that you might want. And we have another example of that later on. But this is kind of a quick intro to Docker exec. And probably one of the most useful things to do with it is connect a live terminal to your container just so you can see what's going on in there. So what other helpful interaction command to know for your Docker containers? Getting a full shell on it is useful, but sometimes you actually just want to connect to the process. So like, let's say you have an Express server, which for the non-JavaScript people is just a simple JavaScript web server that you can run, and will be in our example later. And you know that you needed to run like a yarn start in order to start your system, and you know that you have a lot of logging going straight to that process as part of the way that you've built the app. Well, if your yarn start is the command that your container starts with, and you want to see those logs directly the way you would as if you were running it in your own terminal, there's a command that can help us with that. And that command is docker attach. So docker attach is going to connect us to the live process that the container kicked off with. So in our case, we're going to do docker attach. And once again, we're going to do our Ethereum node, which is just the name of the container again that we've been interacting with. And so we'll hit enter on this. And you don't see anything happening right now, but what I'm going to do here is do a control C, and it's going to feed that directly to the Geeth process, which is actually going to shut my Ethereum node down because I'm now connected directly to this process. So if I do my control C, there it is. You can see that we got the interrupt and that it's actually starting to shut down. So this is just like hitting Command C on like any server that you're running or any other process that you might be running in your terminal. And it went straight to the container instance because we did this Docker attach. So when I did that control C, the running process took that as, oh, I'm supposed to be shutting down. The Geeth process stopped. And actually, as a result of this, if we do our Docker PS again to look at our running containers, you're going to see that the container stopped altogether because the process that it was running with got an interrupt when I sent it that control C. So the Docker attach can be a pretty useful way to watch the live output of the process that you ran in your container, just to see whatever is going on with it at the moment. So Docker attach and Docker exec are two of the most useful commands to kind of interact with your running containers and get an idea of what's going on with them. We are good to move on to our next section here. We're going to talk about building containers from a Docker file. So with this one that we had over here, we were just pulling directly from the Docker Hub using this Ethereum client Go in order to pull from Docker Hub, get the image that they're hosting publicly there, and kind of run it that way. But the other example we talked about was when a specific project shows you a Dockerfile or distributes that in their GitHub repo. So that's the example we're kind of going to hit here next. So I'm just going to clear out this side and we're going to focus on this left terminal here. And basically to keep going with our Ethereum and Ethereum Go client example, I'm actually going to clone their GitHub repo. And if you're following along in my GitHub repo, this is right under the building containers from Dockerfile section. And there's a 4-command section here that we're going to run through. I'm just running the first one here now. And so we're going to go ahead and clone this. This part does take a second. This is a fairly substantial repo that they have here. All right, we have cloned our GitHub repo and we are ready to go here. So I am just going to CD into that. And sorry, that is Go Ethereum here. And then following along in that same section, there are those 4 commands that we want to run. We've done our git clone and our CD. Now, before I run this next one, I do just real quick want to show that here is the Dockerfile inside this Go Ethereum repository here. And you can see that this next command is a docker build. I'm going to put a period -t Geeth. All right, let's break this command down again for everybody. So now we're running a docker build with the subcommand. And what build is going to do is it's going to take a Docker file, the specific type of file, and it's going to turn it into a live image that we can then use in our Docker run command to create a container based on the image that we build from these instructions in the Docker file here. This period here is just setting the build context. So since the Docker file is in this Go Ethereum folder, we're actually just pointing it to the current directory and saying, there's a Docker file here, so I want you to build the Docker file from this directory. You can set this to something else, but the most common format that you're probably going to see for this is going to be this Docker build period. And it's always, again, just setting the build context. You're basically telling Docker, where is the Docker file that I want you to use for this build? And then this -t flag here is setting a tag on the image. The tag on the image is basically telling you when you do a list of all of your images that you have locally, what image is there and what is this particular image named. Again, this is another place where you can get a lot of sprawl. My own machine probably has 100 container images right now just locally. And if I don't add a tag to kind of keep an idea of which one is which, it makes it a lot harder to keep track of what your images are when you have so many of them installed on your machine. So definitely always recommend adding this -t flag, even though it's not specifically required in order to run this. Cool. All right, so for right now, we're ready to go. We're going to build our Docker file to create our image, and I'm going to hit enter here. And here we are. This is the expected output here. What Docker is doing right now is reading all of these instructions from the Docker file and doing all of the steps that it needs to in order to build the image. And it's going to tell you piece by piece what it's doing with that. So basically it's just running through each of these steps in this Dockerfile and reporting to you as it's doing it. It's even telling us how long each specific step is taking. So as you can see, most of this up until now has been pretty quick, but this go mod download part is taking the longest. This is another great example of why distributing your software as a Docker container can be so helpful. Because let's say you have 1,000 people that you want to send your software to, and this is taking up to 5 minutes for this go download or this npm install or for anything like that to occur. Instead of making them do that process and have to wait for all of the stuff to install to their local machine before they can get running, these installations have all been run directly on your Docker image. You send them the Docker image and they're able to just pull that and immediately start running your software without having to do the installations or any other configuration steps that might be required. So this is another great example of why distributing your software as an image can be so helpful to drive adoption and just let people start working with your software as quickly as possible. And my tangent ended just in time because here we are. We've got a built Docker image ready to go. Now, before we actually run a container with this, I want to show you one more useful command here just to kind of keep track of things. We have our image, and so what we're going to do now is this Docker image ls. Again, image is just another sub command, and ls is just like what you're used to seeing if you run it on a directory. It's just telling us what images we have on our local machine here. So a subcommand of this image command. And so when I run that, again, this is what I was talking about where I have all kinds of different repositories here. But you can see at the very top, we have our Geeth image that we just built. And you can see that this was built 43 seconds ago, and it's taking 64 megabytes up on our system. So rather than pulling that container image from Docker Hub, where it's hosted publicly, we now actually just took the Dockerfile from Ethereum Go's repository, their GitHub repository, and we just built that image for ourselves on our local system. So again, rather than pulling this from somewhere remote, like you would if you were cloning some software from GitHub, we're actually building the exact same thing that they have hosted publicly, except now we've got it on our machine. And if we wanted to make any modifications to their Dockerfile in order to better suit our needs for what we need our Ethereum client to do, we could absolutely do that, rebuild the image, and run the container with whatever steps that we need in addition to what they would normally do. But again, that Docker image ls is just going to show you everything that you've got installed locally here, and now you're good to go. All right, and the next part here is actually running the container that we just built with that image. So the last step in that 4 command line that we have in the building containers from Dockerfile section of the GitHub repo is this docker run -d --name test Geeth and Geeth. Quick breakdown again, this should look a little familiar by now, but just to make sure we're all still following, Docker run is just what we're using to build a live container with the software. This -d is just putting it in detached mode so that we are not connecting our terminal directly to the container as soon as it spins up. We're giving it a name, again, just so we can keep track of which container is which. Don't have 1,000 names of nonsense that mean nothing to us and can't keep track of which one. And then Geeth is the image name that we just used in our Docker build command. So from this -t flag in our Docker build, that's now what we're using in our Docker run to point it to the image that we just built in that last command. And so I'm going to go ahead and run that. And once again, good news, we've got our container ID here, which means that we were able to start our container successfully. And this looks very similar to the output that we had when we did the Docker pull and the Docker build from the image that was on Docker Hub. We basically have the exact same ports open. We have everything ready to go. Honestly, in this Docker run, I should have actually even had the -p flags again, just so that our local system was forwarding the port connections to that. But if we do our Docker exec again on this and do it on test Geeth, the name of the container, and do our bin shell, I'm going to come back here and put our -it so we get our nice terminal input here. And if we do that, once again, we can see that here is all of our Ethereum files. So we have the exact same image from building it ourselves that we would have got from pulling it from Docker Hub from Ethereum. So that's kind of the power of that. Is this enables us to build this from anybody's GitHub repo, so that any project that doesn't have their stuff on Docker Hub but does distribute a Dockerfile in their GitHub repo, this enables us to build that image ourselves so that we can still use their software as a container. All right, so coming back to our slides here, here's those 4 commands that were the same as what we had in the GitHub repo there. So congrats, you've made it this far. We know what an image is, we know where to find them, we know how to build them. But we've only looked at other people's images so far. What about when you write your own dope software and you want to put that out to the world and let everybody else use it? So this is the part where we're going to actually talk about building an image from what you've written in the code that you have. All right, so coming back to our terminals here. At this point, we're going to go ahead and start talking about the Dockerfile instructions and what building this actually looks like. So in order to build a Dockerfile, there's a few things that you want to be aware of going into it. And it's really just having some familiarity with your own software. When you've written your software, what needs to happen before somebody is able to use it? Completely removing Docker from the discussion here for a second. Like if somebody wants to run your software in the repo that you've built, what do they need to do first? Is there software dependencies they need to install? Are there config files that they need to make updates to? A lot of the common stuff that you see in a README where it's like, update your .env, don't check it in, don't remove it from the git ignore, all of those types of things. Those are the types of things you want to have in your head before you start trying to build the Docker image for it. Now, just to give you a quick demo of the software that we have here that we're going to use for this, I'm going to actually just kill these real quick. All right, and we're back to just our quick start here. So this quick start is what we have open in our left panel here. And you can see there's not a whole lot, but there is this server.ts that we want to take a look at. Here is my extremely awesome Express server that's going to change the world, and I can't wait for everybody to use it. And all this is really doing is taking a GET request, and when we get the GET request, it's just spitting out a Docker makes life easy. And this is just like any other JavaScript project. And I happen to know that as the person who wrote this, there's 2 things somebody needs to do before they can run this. I need them to run yarn install, and then I need them to run yarn start. So the first thing we're going to do, just like we would with any other project, is I'm going to do my yarn install. Given that I've been playing with this for a couple of days, you can see I've already got everything there, but your yarn install might take a few seconds just to get everything it needs. Not a ton of packages in here, so hopefully it's pretty quick. Now that I've got my dependencies, I'm going to run my yarn start. And as you might be used to seeing with any other Express server, there it is. It's ready to go. It's listening on port 8080. So I'm going to go ahead, just to make sure that I know this is working correctly, I'm going to go curl this on localhost port 8080, since that's where I'm running my web server right now. And there we go. Docker makes life easy. Couldn't have said it better myself. So that's our running Express server. That should be, it's just like any other software that you might run, whether it's a Flask server in Python, whether it's like a Lens or a Chainlink external adapter, like whatever it might be that you've written, we're just starting this the exact same way. And we're going to kind of feed that instruction right to our Docker container now. So at this point, I am going to kill my web server there. And we're going to start talking about what's going to happen in the Dockerfile in order for us to get this exact same output, but in the container instead of on our local machine. So in this Dockerfile, you can see there's a handful of instructions here, and we're going to go line by line through these. The first thing I'm going to advise everybody of, if you're using Docker consistently, there are a lot of good plugins, especially for VS Code. I'm sure IntelliJ stuff probably has all of this as well. But if there is a Docker extension out there, definitely download it. And you can see I've got just the regular Docker one installed right there. So definitely grab that. It's going to make your life a lot easier. And I can show you exactly what I mean by that. So here are all of these Dockerfile instructions. And when I'm hovering over any one of these instructions, thanks to the plugin, I've got the live info straight from Docker's documentation about what each of these instructions is doing, which is extremely helpful because Docker's documentation is very hard to read. It's very hard to get the info that you need. It's extremely informative and in-depth, which is great, but it's so hard to read. And I say that as somebody who's been dealing with these for a long time. Now that we've got our extension installed, let's go through these instructions. So the first thing we're doing here is we're saying from node 1620. What does this mean? Well, the from command sets the base image for us to use for subsequent instructions. What that means is that we are pulling this node 1620 image as our starting point. And I can show you exactly what we mean by that. Once again, if we go back to the Docker Hub, here is the node image. And somewhere in here that I'm not going to try to find the exact one, but here's close enough, right? There are these 1620 images. And what that is doing is pulling node version 16.20 and installing all of its dependencies. We're pulling the image that has all of this stuff installed already so that I don't also need to go through the process of trying to install NPM and Node and Yarn and all of these other tools that I might need in order to enable somebody to use this container. So really what this is doing is it's pulling from an image that has all of that stuff installed for us already and saving us a bunch of time so that we don't have to go do all of those steps. So pulling from with your Docker containers is usually a very good idea. The question is okay to deploy on Docker desktop? Absolutely. I personally am used to the CLI flow, so that's what I use. You do see that I do have a Docker desktop over here. This is a very useful interface, especially if you're not as comfortable with the CLI, but do want to still use some of the functionality of Docker. They've made it very easy to do a lot of the functionality in here now. Like instead of running my Docker kill and Docker RM on one of my containers, I could just click this delete button here, get rid of it all that way. So to answer the question, yes, you are more than okay to do whatever you want in Docker desktop. I'm just showing the workflow that I'm a little more used to, but if this is more comfortable for you, highly recommend it. But all right, coming back over here. So that's our starting point, is this from node, so that we have Node.js, NPM, all of that good stuff installed. The next command is copy. And copy is copying files or folders from source, which is the first argument, to destination in the images file system. So in our example, here's what we're doing. We're copying everything in our current directory. Seeing as the Dockerfile is here and all of these other files are included in this directory, it's copying all of this into the /opt/express directory in the container image. So when we actually spin this container up after building the image, it will have all of these files added into the /opt/express directory. And we'll connect to it once we build it, just so you can see exactly what I mean by that. This next command is workdir, and workdir is setting the working directory of any subsequent commands. And really, it's just like running a CD. So if I were to run CD mount over here, workdir is doing the exact same thing, except in the context of the image build. And the reason I do that workdir there is because if all of my Yarn packages and all of my software is in this directory, because that's where we copied it all to, I want to make sure that I run my Yarn install inside this same directory so that it actually knows where its package lock and all of that is going to be. So we're changing to the directory that's going to have all of these contents, and then we're running our Yarn install inside that directory so that it has exactly what it needs to go execute that. And that's really all this run command is doing, is just running whatever command that you want it to. So in our case, we had 2 steps before somebody could start our software. It was a Yarn install and a Yarn start. So this is meeting the requirement to install those dependencies inside the image so that anyone who spins a container up from it already has that stuff installed. They don't have to sit there and wait for it. This next command here is expose 8080. What expose does is actually make sure that the container can listen on the port that we set. So in our Ethereum client example earlier, we were passing the -p flag for port 8545 and 30303. In order for us to actually pass traffic to that port, that Dockerfile that we built from would have needed to have those 2 ports exposed in the Dockerfile. And in our case, since we have an Express server that's listening on port 8080, we want to go ahead and expose port 8080 on the container so that when that traffic gets sent to that container on port 8080, it's already listening for it and it's expecting traffic on that port. And then our last instruction here is the entry point. The entry point is the command that's actually going to run as soon as we start the Docker container. So this is the second part where now we did our Yarn install earlier, but now when somebody starts our container, we want it to run Yarn start. And that will start up the Express server and let that container be ready to go, listening for web requests. A quick note about the syntax of this. You're going to notice, obviously, that it's a little different from this run up above, and you might be wondering, why does entry point need to be like this, whereas run is like this? I do forget off the top of my head if this is like a strict requirement to have it laid out like this, but basically, entry point has like there's a syntax difference that allows Docker to kind of handle some of this better in the background. And that's really the reason for this syntax change here. And you can see when you hover over the instruction, it does give you this exact same format here where it has the brackets and then a quote for each of the things that you want to run with a comma between any of the different arguments. So without getting into the semantics of why that is, because to be honest, I even forget off the top of my head, just be aware that entry point has a slightly different syntax here. And you just want to pay attention to that whenever you're setting the entry point command that's going to run when we start that container. At this point, we did it. We built our Dockerfile. And now that we have the blueprint, it's time to actually build the image with it. So we're going to come back to our GitHub repo here. And again, now we're in this building your own images section here. And there is a Docker build command that is towards the top here. It's after that first paragraph in there. And so here's what we're going to run. And we'll break this down again just the way we have been the whole time. So we have Docker build. And again, this is just saying take a Docker file and turn it into an image. The -t is once again just giving this a name. I want to remember what this image is. The -t is going to give me the ability to do that. So I'm going to give it the -t to say, this is my Docker Express image that I can use to spin a container up later. And then once again, we're just doing the current directory, which is what that period stands for. Again, this is just because if I ls this, we see that in this current directory, and actually this might even be a more helpful way to kind of demonstrate that, but in our current directory, we have this Docker file right here. So when I do this docker build -t docker express and point it to that current directory with the period, it is just defaulting to using this Docker file. One quick note, if you do have more than one Docker file, you can actually give this a specific path to that as well to tell it which Docker file to build. But if there's only one or the Docker file name that you see here is kind of the default. So if this is present in a directory and you just tell it to build in the directory that has that Docker file, it's just going to default to that one and it's going to choose that. But all right, here we go. Let's go ahead and build this thing. I forgot something. Docker build would be helpful in front of the -t there. Knew I couldn't get through the whole thing perfect. All right, and just like we did with the Geeth node earlier, we're going to run a build. This one is much smaller. We only have a few packages that we've got to install, but you can see in the output here that we've got our specific instructions in each of these, and you can see that happening as it's doing the build process. Now it is exporting to the image, and now we should have a perfectly good to use image on our machine. And just to check again, we can once again do our Docker image ls. This is just checking all of the locally installed images that we have. And when I do that, you can see that actually I already had this one somewhere in here. Yeah, so I didn't make any updates to this since I last built it, which is why it's showing us the 16 hours ago. When y'all run that, it should be the first one that pops up here, and it should say that it was just built a few seconds ago. Since it, again, mine was cached, it had all of this already built from when I was running through this last night. But same thing here. This is my Docker Express image. This is where I'm wanting to see it, and we know that we have it on our local system. So now that we've built our image, it's once again time to actually run the container with it. So if you're following along in the GitHub repo, we're going to move past where we have the output should be similar to this. And we have another Docker run command with, again, the breakdown of what these are going to be doing. And let's talk through this one more time again. Y'all should be getting pretty used to seeing these by now, but we've got our Docker run. We've got our -d for detached. It's not going to connect our terminal to it. We've got our -p to tell it what ports to use so that when we send our curl request to port 8080, our local system will be listening on port 8080, and it'll forward it to the container's port 8080 so that the Express server running on our container is getting that request from our local machine. We are once again naming our container so that we can keep track of which one is which, and we're using the Docker Express image that we just built in our last command up here as the basis of what we want to run this container with. So let's go ahead and start that. And yet again, we get a container ID, which means that that built successfully. If I do my Docker PS again, there is my test express with all of the info about what's running in this, including the yarn start as the starting command. So remember, when we started the express server on our machine, we did our yarn install, we did our yarn start, and then I had that directly in my terminal, just showing all of the web requests that came to that. Now that's running on the container instead. So the Express server is still running, but it is within this container that we just built. So at this point, once again, we should be able to do a curl for localhost on 8080, and we get the exact same result back. So this container that's listening on port 8080 is running the exact same Express server that we were running on our machine when we did yarn start, except now it's running within this container, and we're able to distribute this to anybody who wants to use our software the same way. So that's kind of the very quick overview of how to build your own images with software that you've written. Just going back through the section here. Yeah, curling, that's the last step there. And exactly as you can see, we got the same result. We were happy. It did exactly what we wanted it to. But all right, let's take a quick breath, everybody. We've got a lot that we went through, and the last step that we're going to go through is some extra tips and tricks to help you go even further with Docker now that we've gotten through the basics here. Here is our tips and tricks, and I have not forgotten the security question, and we're about to get to the point where we're going to talk about that. Before we get there, tip number one, name all the things. I've been harping on it the entire presentation, and I'm going to harp on it again here. If you don't name your images when you do a Docker build -t, and you don't name your containers with the -- name when you do a Docker run, it's just very easy to lose track of all of the things that you've built. It might not seem like that big of a deal when you've only got that one image and that couple of containers that you've built so far. I can tell you though, as somebody who uses this in my workflows all the time, my image list is a disaster, and I'll show you a screenshot in just a second of what this starts looking like. But image tags help you keep track of the names just to know which image is which. The other thing that we didn't really do in the presentation, but we did kind of point out in Docker Hub, is you can use that -t to specify more specific tags as well. So this is kind of a good example if we go back to the Docker Hub here for Node. Where there is that latest tag, there's also these other tags. So just to kind of show a very quick example of what that would look like, if we were doing our Docker build for Docker Express, basically, if we had made some change to this where, let's say this is running now with Node.js 18 instead of Node.js 16 like we chose, we could actually put a colon here and do a Node.js-18, just as an example. Now we still have our same Docker Express image name, but we're giving it this extra tag to help people know which exact version might be the best fit for them. So again, coming back to Docker Hub, you can kind of see what this looks like. And you can see here that this Docker poll node :slim is that exact same format. This is the specific tag that gives you an even better idea underneath that image name of what a specific version that image is. So that's another way that you can kind of further break this down. If you have multiple versions of the same image that you want to give to people, this is kind of a helpful way to do that, just to give people the different versions an idea of what they might be running. So that's one thing to keep in mind for your images. And then with your container names, again, -- name flag. If you don't do that, if you don't do that, all you're going to get is the container IDs like this. And again, it starts getting pretty hard to keep track of what's what after you've got about 10 of these running at the same time. So tip there is just name everything, keep track of your stuff. Later you is definitely going to thank you for that. Here's what it looks like when you run a Docker image ls when you don't follow my advice there. This is a disaster. I don't know what the vast majority of these are. And look at how much space they're taking. I'm wasting gigs and gigs and gigs with these images, which you can see on the sides with the size flag over here. I'm wasting multiple gigs of file storage, and I have no idea what all of these even are. So this is why you want to do that Docker build -t, because otherwise you're going to start looking like it's on my computer, and you definitely do not want that. So use that -t flag, keep an eye on your stuff, and name all the things. The next trick is use dockerignore to reduce bloat. All right, coming to the security question. Let's talk about Docker security. Yeah, when it comes to downloading public images, you do want to use the same amount of caution that you would with anything else. Just like you shouldn't necessarily blindly clone a GitHub repo and immediately feed its setup.sh into your bash with, running as root without any idea of what it's doing. Same thing is true for a Docker container. Maybe get some idea of what's going on there first, do just a tiny bit of due diligence, and make sure that they're like the official images from Docker Hub as well. Something else that you can keep an eye on there is like this Docker official image. So when this comes to Node, always be looking for these. If you see a Node lookalike, but you don't see like Node actually in your URL and you don't see this Docker official image, that should be setting some red flags off for you where you're thinking, maybe this isn't the container I'm looking for. I should double check. This is the same thing too, where it's like, maybe don't click the link that just got sent to you randomly through Discord. Same thing applies here. Like if you get a really random Docker Hub link that has no verification, there's like no downloads on it, it looks super sketchy, you're probably right. It probably is sketchy and you probably don't want to run it. So I didn't have that in the presentation, but it's a great question. There's a few things to keep an eye out for when it comes to downloading your own images from public sources. While that's one side of the security story, the other side of the security story is what you're publishing. Just like you shouldn't be adding your .env to your public GitHub repo, you also want to be careful about what type of stuff you're adding to your Docker images. Let me tell you a story. There was a Docker image that was posted for Vine, which was the old school TikTok back before TikTok was a thing. Twitter bought it, all of that. A developer accidentally posted source code and secrets to a Docker image that made its way to Docker Hub. Everybody was able to go clone that image and create containers from it, and they essentially had a breach. That information that was supposed to be private to Twitter was now public to the entire world. So one thing to keep an eye on is when I'm building an image and actually posting that to Docker Hub, if I go that far with it, what am I posting and am I being careful about what I'm putting in there? The best way to kind of keep track of what you're doing and what you're putting into your image is by using a handy file that is called a .dockerignore. This dockerignore really does two things for you. It's just like a gitignore, first of all. So you can think of it the exact same way, fills the same type of function, but it helps you prevent bloat on your images. It helps you prevent adding a bunch of stuff on your image that doesn't strictly need to be there just from a bloat perspective, so that you're not making your images run slower or take up too much disk space when they don't need to, stuff like that. It can also help you make sure that you are not adding secrets or anything that you don't want in that image as part of that as well. So if we go back to our repo here, we have a .dockerignore. And we haven't touched on this yet, but I'll show you all what this all is here. So this format is going to be exactly the same as what you're used to a .gitignore, like I said. The thing to note about the difference with the .dockerignore is that what this file is really doing is it's keeping an eye on your instructions. And we have this copy command. And when we ran that copy command as part of our image, we copied all of the contents of this folder and we put them in this location on our image. What this dockerignore is doing is saying, hey, you can copy everything from this directory, but anything that I have specified in this file is not going to be copied into the image. So a few examples. We have our .git as part of this repo. That is completely irrelevant to what's running on the container. It doesn't need to be there in order for the container to run. So instead of including all of this info about my branches and all of the things that I have on my GitHub repo, we're just going to dockerignore it, and it's not going to get included in the image, again, because it just flat out doesn't need to be there. Same thing with the .gitignore. It's not helping anything. The yarn lock and node modules, this stuff kind of could be up for debate. There might be cases where you actually would want to include this in your image just so that anybody who runs it has the exact same packages and starting point. In general, though, I tend to think that maybe it's not the best idea. We're already going through the process of installing everything that's needed as part of the Dockerfile. So in this case, I just went ahead and included those in the dockerignore and didn't add them. There may be cases where you actually want to include these in there, though. So kind of a case-by-case basis to think through on what you would want to include in here. So that's kind of the overview of the dockerignore and what that does. Again, it's just to kind of help you reduce anything out that doesn't need to be in there and maybe exclude files that have secrets as well. Just to show you all too, I have this /mount folder and then this .env. I'm going to commit a cardinal sin and show you the .env. because it is definitely not a real password. So I promise I'm not putting my wallet key out there for you all to get all of my stuff out of there. But let's say you have this .env and it does have a private key to a wallet because you need to build a signer in Ethers and you need to be able to submit transactions as part of your code. You don't want to include that in your image if you're going to push that image up to Docker Hub and have that be publicly hosted. So this dockerignore is really targeting this .env within this .mount. But if it was just a .env in this same exact folder, same thing. You would just specify the .env folder, .env file in your dockerignore, and it'll make sure not to copy any of those files into that container if that's not an intended purpose of that. All right, and that's pretty much all I've got on the .dockerignore. Again, just think about it as a .getignore. Always make sure you use it. It's one of those things I personally try to include in every Docker container that I build, just to make sure that you're not going to include anything that doesn't need to be there. All right, our last trick, mounting local directories in a container. There are a few different ways to do this. We're going to focus on a pretty basic use case here. It's possible to mount directories on your local file system in a container so that the container has access to them. This is another place where, specific to Web3, I think this can be pretty useful. Let's say you have that folder with a .env or your .ethereum client if you're running that locally, anything else that might be a secret, and you want it to be inside the container image, but you don't want to copy, or sorry, you want it to be in the Docker container that's running so it has access to your secrets, but you don't want to include it in your image so that when you push your image out, everybody who clones that doesn't have access to it. Mounting local directories can be a good way to kind of solve that problem. It can also just be super convenient if, let's say, you have a piece of software that like makes a bunch of edits to an Excel file and you don't want to copy that file in, you just want to mount it from your local directory. That's another use case that might be really useful to just use a mount in that case and kind of run it that way. So we're going to go back to our command line here, and I'm going to clear all this stuff out. And if you're still with me and following along in GitHub, this is close to the very end here. This is in the trick mounting local directories in a container, and it's the first of two commands that we have there. And I'm copying directly from that myself. And this is going to look pretty familiar to you at this point, but there's a specific flag that we need to point out here, and it's this -v. -v is for volume. And we've talked about how you take something from local and move it into remote. And anything on the other side of this colon is usually going to be the remote, right? So just like here with our port, we have port 8080 on the local side. On the other side of the colon is the remote side where we're going to actually put that or what port is going to listen on the container. Same thing here. On this side of the colon, this is what directory we want to mount from our local machine. And this is the location within the container that we're going to mount that file or directory to. This PWD thing, I hope that isn't too confusing. Basically, that's just taking the output of the print working directory command, which just grabs the exact directory that you're in and places it in front of this /mount, just so that the repo doesn't make any assumptions about where you've cloned this and potentially mess you up when you're trying to copy and paste this command later. So that's really all that that's doing. But let's actually take this again. And we're going to run a new container, this time with a volume mount. Oh, this failed. And if we take a look at why, it's because I'm still running a container with port 8080. We can't use the same port twice. So real quick, good troubleshooting exercise. I'm going to do a Docker kill on test express. And then I'm going to do our Docker run again. This is freeing port 8080 up, so we should be able to do this now. Except now I built a container that failed on the last run, so I have to delete the container that failed before I can do it. Sorry about that, but again, hopefully helpful. So I'm going to Docker RM mounted express. There we go. If I do a Docker container ls, okay, I have no containers running. There's nothing going on anymore. This time it should really work. Third time's the charm. We got our image ID back. If I run my Docker PS again, there we go. We have a new one named Docker Express. And here's our other example of Docker exec, which I promised you all earlier. Docker exec, again, is just going to run a specific command on the container that we tell it to. So to break this down one last time, mounted express is the container that we just created in our command above. this is the entire command that we're now going to run in that container. So this time, instead of doing the -it and including the -bin bash to actually connect a live terminal to the system, all we're doing is running a cat inside the system. And if you don't know what the cat command does, it just reads out the contents of a file to your screen. So this time we're just running a cat on opt express secret.env. The reason we're choosing that specific directory there is because when we did our mount, oh, did I actually get the wrong? I may have even actually gotten the wrong one there. Let's try that. Okay, somewhere along the way, I jumbled up my terminal there. But when we ran our Docker run this time, I'll copy the command that we originally pulled from there. This time when we did that, we took the contents of our /mount, which is what's in this folder right here in the GitHub repo. And you can see that there is this .env. We took the contents of .mount and mounted them to this opt express secret. So when we're running this cat opt express secret.env, this should be showing us the contents of this file over here, since this is now mounted from my local file system directly into the container itself. And as you can see, we have our super secret password that is now printed to my screen because the mount worked successfully. So rather than this file being there because of the fact that we copied everything in here, the way that this actually worked was when I ran this copy of all of these files in the directory, this file did not make it. And the reason it didn't make it is because I ignored the mount folder in my .gitignore, which prevented this whole folder from getting mounted in there. But when we ran our command, we added this volume mount, which now takes the contents of this mount folder, puts it at this opt express secret location. And then when we ran our Docker exec against that container with a cat to read that file out, that's how we ended up with the contents that we were expecting there. So that's kind of a quick overview of mounting your local file system and getting files in there that way. Again, this can be a useful way to add in secrets to your container that you don't want present in the image, or just to make things a little bit more convenient if you just want to mount your entire documents folder in there and take actions against them in there like that. At this point, though, that's all I got, folks. Thanks for sticking with me. Thanks for tuning in. If there's any other questions, I'm definitely happy to answer them. But that's basically all I've got to teach you about Docker today.